Fantastic. Hello, friends. Welcome to this new course on Kubernetes. This is a more like an introductory course, and this is going to be more interactive. So I welcome all silly questions, all basic questions. Don't be hesitant to ask any question. This is your window of opportunity, and more basics. You can build upon that knowledge. But if you have some unknown areas and if you are having any hesitancy or fear to ask, then that area it will take more time to gain knowledge. So and as one quick deviation, I want to go and show you this link. 100 YouTube Kubernetes playlist. There is lots of YouTube videos. Many people have done. That's like more than 1,000 Kubernetes related videos. Link are provided in this page, and I'm going to add more over time. So there is lots of knowledge which you can gain at your convenient time. So this intention of this particular training is to, from your point of view, ask me all questions so that you personally get clarified. And personally for me, there's also a learning experience for me. Like more question you ask, it is like looking at Kubernetes from a different point of view. And the second focus of this training is at the end of every session, beginning from tomorrow onwards, there will be hands-on lab exercise. And it is mandatory that each one of you spend time before the class itself to do these hands-on sessions, or else if most of you are not able to do it, then all of you has to do it before we start the actual next session. So this is the two intention. One is ask away all your questions about Kubernetes as time progresses. Second thing is you have to do in each of these end of 10 sessions, I'm going to add the lab exercise. I've not updated them yet. I'm going to add the lab exercises and you need to do it before the class, which is going to start from the next class. But this class is going to be mostly a lecture where I'm going to take you through the slides and couple of videos, and you can stop me and ask me questions. Okay. So does anybody has got any question before I start? No questions? Okay.
Yeah.
Go ahead.
Jay?
Yeah.
So this is the second batch of the rollout of Kubernetes training.
Correct. Yes.
Okay. So what's the real thing which you have experienced in the first batch, which you wanted to align it in the second batch? Interaction is one key point, as you told.
Correct.
And other than that, have any other requisite you stress on?
None. Like and first batch training and the second batch related, like unrelated. Like they got trained and that training ended. It was a learning experience for me also. And with that knowledge, I've actually even changed some of these topics and added and removed based on what I learned. Yeah. So this particular training is nowhere related to the first training from the participant's point of view.
Fine.
Okay. Thank you. Okay. So now this slide, I hope all of you will have access and you can come back and see also, obviously. Now, what is Kubernetes, right? The name, some of you might not have heard, some of you might be already working. Google, as you know, is a large company with tens of thousands of servers, and they have fundamentally they had Google search and then YouTube and Gmail and Android environment, and they're a huge company. So for more than 20 years, they were not using a full operating system. They started with Solaris operating system, then migrated to Linux. And then even like 15 plus years ago, they did not want to have a full Linux operating system to run everything, because they want to make it as small as possible and remove all fat and unnecessary applications. And they made it as small as possible. And then they created a orchestrator platform, because when you are having like millions of millions of your application component running in a huge data center, which is globally distributed, you need an orchestrator to manage this million. Like you cannot, create and deploy a container or your application component and then scale it up, scale it down, patch. You cannot do it. So they created an orchestration platform inside Google. They called it like Google's Borg, which even like 10 years ago, based on their papers which I read earlier, they were spinning up and spinning down billions of containers per week, like 10 years ago. Okay, so for nearly 10 plus years, they were doing all this thing. And then when cloud started, Amazon cloud came first, then Azure and Google Cloud, many clouds came. At that time, fortunately for us, somebody in Google decided, hey, why don't we take all this knowledge we built and then which built over decades with thousands of smart people, which scales and battle tested in running Google's multiple website. Why don't you create an open source like Linux, which they're using internally, and make it open source and give it to the public? Is what some good, fortunate soul thought. And they built a small team and they took all the good ideas of Borg, which it was running, all the abstractions, how to run Linux in scale, and created a project called Kubernetes and released it as an open source to a non-profit organization called Cloud Native Computing Foundation, which is actually part of the Linux Foundation, which is also a non-profit. Because Google doesn't want to, keep it themselves. They made open source, release it to the world. Not only that, they also help to create this Cloud Native Computing Foundation, who will be the torch bearers, or the open source non-profit organization under whose umbrella this Kubernetes will develop, and along with all the tools, right? So they've released it as an open source. Fundamentally, that is the story. And then it's when they were brainstorming for the name, they were thinking of many names, and one of them, decided to call it as a Kubernetes, which means a helmsman of a ship, like the people who run the ships. That's called Kubernetes in Greek language. So they just set up this name. So this is how the whole Kubernetes project got started and released to open source 6+ years ago. And it's a rock solid code, and the code might have been released in 2015, but then the ideas how to scale up and scale down and upgrade and how to do self-healing, all those ideas they already learned and practiced and battle tested by running Borg. So all those ideas and abstractions they brought in, and then they coded it as Kubernetes and released as open source.
Jay,
Right? Yeah.
Can you spell it? Borg, or what is the first name?
Borg. Borg. Google's
Oh,
Borg.
yeah, Borg and Omega. Okay.
Correct. If you Google for Google's Borg, they have actually written multiple research paper how Borg works.
White papers. Okay.
Yes, you can get an understanding. Obviously, it is hugely complex. It is big, and they did not release Borg to public. They started from scratch, but with all those ideas how Borg runs, all the team who are managing this Borg, the team Google took a dozen plus people and then said, hey, look, create something like what Google is running on production.
Fine.
Right, so that the code base should not be the same, right? The copyright problem potentially, and then if there's a security hole in Kubernetes, if somebody finds out, then maybe they'll think, okay, Borg also will have the same security hole, and maybe they can hack also. So the code base started from scratch.
Yeah, thank you.
Okay?
Thank you.
Pleasure. Okay, so now I will also, in parallel, I want to go, where does Kubernetes fit in the big picture? When I started more than 20 years ago, my career in IT, like Unix was the big deal. Like, companies really used Unix in their premises. But then when I was like in school and all, I've heard like mainframes were what were used. And in this world, even now, some companies use mainframe, and many hundreds of companies still use Unix. But then after year 2000 and all, when dot-com boom came, and like lots of people entered IT, and everybody wanted a website, and then there was an explosion around 2000. Then Linux and Apache became a very like famous thing to do, because Linux and the Apache web server, like both were free. And then they used to call LAMP stack, Linux, Apache, and then Perl, PHP, or Python, and MySQL. So this combination was used to build millions and millions of website. And then obviously Windows Server also came into picture in the data center. And these were not even virtual. Like you need to have a physical server and install using a CD or a USB, a Linux or Windows server in the data center. And then you will install, if it is Linux, Apache, and later Nginx web server came, or if it is Windows, IIS, or Apache, because Apache run on Windows also. So they install, they build websites, and that is how the companies used to have their own data center. And after year 2000, virtualization came where in which there'll be one physical server, um, and then you'll install a virtualized operating system such as VMware or Linux KVM, Linux kernel virtual machine, or Zen, which came later. On this, you can have like 10, 20, 50 Linux and Windows operating system in a virtualized environment. And then each of those operating systems are isolated, that you can create 10 Linux and 10 Windows. All of them will run on one physical server in a virtualized environment, and you can reboot and patch any server you want at any time. And one Linux server don't know that it is sitting next to 10 other Linux server, because the CPU memory disk will be virtualized and given by this virtualization layer, which is done by VMware or Linux KVM, right? So that is what became the de facto way of installing servers from 2000 to like even now, right? On premises, virtualized environment using VMware or KVM, using Linux or Windows, and using Intel and AMD x86-64. I mean, earlier it was 32-bit, but now there's no more 32-bit microprocessors. It's only x86-64 only from Intel and AMD on a virtualized environment in the on-premises data center is what people started using it. And if you look at Unix, see, Unix is like 5 to 10 times more expensive than Linux or Windows. And Unix needed specialized microprocessor. Like if you want to have Solaris, it can only run on Spark. If you want AIX from IBM, it will only run on Power Series AIX, Power Series microprocessors. If you want HP, now it can only run on like Itanium or other specific HP UX Unix will only run on specific microprocessors. So and those hardware were like 10 times more expensive than this Intel and AMD, whether it is 32-bit or 64-bit. So they're 10 times expensive hardware wise, and also the Unix licensing wise, which Linux, which is free and open source, can do it with the same capability. But then Linux is like even better than Unix these days. So this is how the on-premises data center came into existence. So every medium, large companies, they used to have their own on-premises data center, and small tiny enterprises who just want a website, they used to host it on some web hosting company. There were like hundreds of web hosting company who will allow you to host like a website. uh, Obviously they will also have Linux or Windows using Apache or IIS only. But then the small companies with less budget, they don't obviously want to bother to manage it, have their own data center, just pay a few hundred rupees or few $100. These ISPs or web hosting companies will host your website, and they'll charge you per year, right? So this is how it evolved. And then after, like, Amazon got into, I mean, created this whole idea of cloud computing. And from what I've heard from some of my friends, the reason they created was, see, Amazon was a retail company, right? They initially started as a book selling company, and then they started selling multiple other things. Then at Amazon, this November, December is the 2 months where they make like more than 50% of their sales, right? And especially the Black Friday and the Christmas period is where, like, there are few days where whatever the whole month of March, that month worth of sales, they used to get like on a Black Friday, or now December 26th, the website traffic is like so much, and that one day it will be equal to the whole month of March, April, May, June, July. Okay. So then somebody in Amazon thought, okay, so we are selling many things, and then for 10 months in a year, let us assume they had, like, 10,000 servers for November and December. Okay. But then from January to October, they're only using, say, 1,000 servers for all of the traffic, right? So they're using 1,000 servers for 10 months. And the 11th and 12th month, they need to have 10,000 servers to support the load. So now business will not agree not to lose that business. So you need to have 10,000 servers. But then January comes, you're wasting your 9,000 servers. You are only using 1,000 servers. So somebody came up with an idea. Why don't we rent out this compute for public? Because for 10 months anyway we are wasting 9,000 servers. So that is how this whole idea of Amazon cloud started. That we are anyway selling many things, let us also sell compute power. Right? But then for initial couple of years everybody thought it's a joke, because like IBM was like, huge company, nearly 100 years of history. They're not doing this. Microsoft is not doing it. HP, Dell, all these, hundreds of billions of worth of hardware they are selling happily. None of them did it. People were laughing like, what happened to Amazon? Like, instead of selling books, they're selling compute, and compute is complex. Like, if you see, I've heard IBM spent more than $1 billion to create OS 2 operating system, and it miserably failed. Like, they lost $1 billion while creating an operating system, that to IBM, which single-handedly invented computing. Right? So everybody that, like, even if the operating system people who are doing from 100 years, yeah, if they cannot do it, how come a book selling online website company can do, like, something called, like, okay, we will give you operating system for per hour basis, right? Then initially it was a joke, like nobody believed it. Like, how can Amazon, a book selling one website, who doesn't know anything about operating system, and then there is Microsoft which built Windows, and there's lots of Unix companies like IBM, HP, Solaris, right? And nobody is even thinking of giving hosting in public. Why would a book selling company do it? Maybe they're trying something trial, and they'll shut down or sell this unit to some other operating system vendor, and they'll close down, is what many people thought initially, right? Because the whole idea of hosting my compute, and which is core of my IT, with all my personal data and my financial data in somebody else's premises, was unthinkable in 2005. Okay. But somehow somebody in Amazon had this problem, like they're wasting 9,000 servers for like 10 months in a year. They said, okay, let us start this somehow, and they started. But luckily they held on to it, and then now it is like, huge business. You all know, from the past nearly 10 years, everybody is going to cloud, like small, medium, large enterprise. Everybody wants cloud because it has got its own advantages. and it is cheap and it is scalable. On Monday, I can run 500 servers for my compute, and on Tuesday, I can only run 5, but I'll only be paying for 5. Like I can get as many servers to compute, and I can shut down all 500 of them or delete all 500 of them. I did not pay anything, right? So
Jay,
yeah,
one small
please.
clarification here.
Yeah,
This is purely from my academical knowledge.
please.
So earlier, when I started my research
Hmm.
in 2006 and 7,
Hmm.
prior to that, we had something called as grid computing.
Correct.
There were two,
Yes.
Carl Cousinman and Ian Foster. These
Right.
guys came
Hmm.
up with an idea of virtual organization and collaboration, and it was the real idea of the cloud, I
Okay.
suppose.
Right.
And what happened is, this is a very strange story, right? Most of
Mm-hmm.
the things you will have, what do you say, like as with Kubernetes,
Hmm.
you had Google working on it and came out with an open source version. When it
Hmm.
comes to the cloud, I think
Hmm.
like it's only Amazon, it has come out with EC2.
Right. Before that, they came
Uh,
with S3 for storage.
yeah,
That is, S3 was
yeah.
the first tool, and then they came with the EC2. Yeah, go ahead.
Yeah. So here, as I told, I may be wrong if you
Hmm.
correct me if I'm correct. What the it is again the negligence of the maybe the consortium or the people the IT based companies
Hmm.
to look around the potentials of cloud. When Amazon took a very competitive start.
And sunk and put billions of dollars believing in that.
Yeah, that's why I say like even like when you talk about interfaces like how do you do a cloud interface, like this is what EC2 happens to be the very first interface, right?
Correct. Yeah.
From an industry, but no, we have never seen such kind of things from industries. I mean, industry in the things, most of the things it will be from R&Ds, right?
Correct. Yeah.
Yeah, this is again a strange phenomenal thing, right? That
Yeah.
is
That's what the operating system people did not create cloud. A book selling
yeah,
website created cloud.
yeah, that's why you may say usually, even if you say Oracle or Google, it has come
Yeah.
from a university, and then it has been made a commercial one, right?
Correct.
Now, this is the case. It is from a commercial company. Now it is made as a standard.
Correct.
So it is again a phenomenal change that where you can say that it's not only that R&Ds can build standards and other things.
Correct.
Even it may come from
Anywhere, some random person. That's what. See, this retail
yeah,
company, they don't know
yeah,
what to do with the 9,000 servers for 10 months. That is their problem. They want to solve
yeah.
this problem and make money.
Actually, when what we were studying in grid computing, they used to say that if
Yeah.
you have your own company where you have
Correct.
invested more of the service, if say we take an instance of a college, we
Yeah.
have some near about 1,000, 2,000 desktops and 10 to 20 servers,
Mm-hmm.
and most of the times it is not utilized.
Correct. Yeah.
Utilization is zero.
Hmm.
Even if it's in the lab hours, it's only in very few, like maybe even in a semester, it goes up to 45 hours to 90 hours.
Correct. Yeah.
Rest of the time, it is underutilized.
Yes. So,
Yeah,
some college student could have come up with this idea. Hey,
yeah,
actually,
yeah,
there are many ideas. You might have heard
yeah.
about that SETI at home,
Yeah, sitting at home was the very first thing where you are able to do your
right?
computational loads, right?
Correct. So it is
Yeah,
like making a supercomputer, right? You're distributing the
yeah.
load.
Virtual
So
supercomputer. Virtual
correct.
supercomputer.
So the ideas were all there. And
Yeah,
also, if you look at multics, even
yeah,
before Unix, like even before
yeah,
mainframe, the whole idea of multics was there will be only one operating system for the whole country, and everybody will
yeah,
do dial-up.
yeah,
After 50 years, we have come back to that idea only now.
yeah. Okay, thank you. I just wanted to put
Correct.
this my observation here for
Thank you.
to
Thanks for sharing. Yes. See,
okay.
academically, there are so many people would have had awesome ideas, and they were doing
Yeah,
grid computing and
yeah,
supercomputing.
yeah.
Yes, and they are smarter
And
people.
they had a middleware also. They've developed a middleware.
Correct.
I don't know. It didn't pick up.
Yes. Yeah.
Yeah, it's called as Globus Toolkit. I remember if I'm correct.
Yes. Correct. Even I have heard about it. There is so much clustering software and so much distributed computing, grid computing were
Yeah,
happening. but none of them came up with this idea of,
elasticity. As it is
yeah,
elasticity
not
of
only
using it.
elasticity. See, now, if you buy any hardware or software, you buy even the hardware, you buy it, you own it, and software also you own it. But then for the first time, Amazon came up with this idea, okay, we will rent it out, the compute and the operating system and everything. And the rental is not even for like 3 years. It's not even for a year. It is not even for a month. It is not even for a day. It is 1 hour.
Flexible.
Right? This, if you call IBM and say, hey, I need $1 million mainframe, can I use it for an hour? They're not going to agree, right? And you know what? I'll tell you one more interesting thing also. So when Amazon came with 1 hour and all, then after a few years, Google also came to the market. And then Google came up with per minute billing.
Oh.
Right. So, and then the reason why I'm saying is that then after that, just 2 weeks later, Amazon also said, okay, we will also compete per minute billing. Then Azure said after a few weeks, okay, we will also do per minute billing. So, so there is so much competition about these people. And okay, one related interesting thing also I want to share. See, almost always, for anything, we only know price will always increase. Whether it is rice or wheat or anything across the globe, price of commodities will always increase, right? For the first time I've seen in AWS cloud, they always, every quarter, they keep cutting the price. This I'm seeing from the past more than 10 years. Something or the other, they'll keep on cutting the price. They themselves, like, forget about increasing, right? The same service, same quality, because they have economy of scale and they have millions of people using it. They save money, and some of them, they want to pass it on. See, Amazon might have decided, okay, let us increase the profit, let us not decrease the price. But they are fanatically about passing on the benefit to the customer and scale up. They don't want short-term profit. So I'm seeing for the past 10 years, every quarter they'll keep on cutting their price, whether storage or networking or compute. Cut is. I'm surprising. Like every 3 months, I'll see an email. Okay, price of EC2 in this size is slashed. And 2 weeks ago, I saw some of their networking prices they slashed. Right?
Yeah, it's really strange.
Unbelievable. Right? And they're growing. And just to compete with them, whatever service they bring, in few weeks, if not in a month, Azure will bring that same service and lower price, and then Google Cloud will bring. So these three large vendors, along with other smaller vendors like IBM Cloud and Oracle Cloud and Alibaba Cloud and DigitalOcean, everybody is like keep on cutting the prices. Which is benefiting us, the consumers of this computing, right? So this is the best time to be alive when it comes to computing and the power and all those things, right? Because 10 years ago, if you want to like provision a server, you have to wait for weeks and months on premises.
One more thing that,
please,
one suggestion. If you can share some good, like what you've been telling about the past, the historical is thing. If you talk about any reports which concretely says about the next 10 years or 20 years of projection of this migration.
Migration from where to where?
Now you're talking about the potential in Kubernetes, right? So how Kubernetes is going to penetrate. So do you have shared any link of that report or white paper which tells about the projection?
I can share for sure. Yeah, in a high level, obviously. And as I put here in my bottom, these dates are real, and this operating system and companies are real. But the sizes are all my opinion.
Yeah. Let me clearly tell you why the intention and just posting your question. Yesterday evening we had a discussion.
Yeah.
Maybe it is for all the participants. Like, what do you think might be the market potential?
The size, I mean, many of there is lots of published reports. Maybe I'll share that as a link at the end of this one.
Please do.
Yeah,
because
but this
whenever
one
at the point
is pure. Go ahead.
Yeah, whenever we just like talk about like whenever it's just like if you wanted to make somebody to learn,
Yeah.
or it is just like a kind of a marketing? Don't take in the other
Okay.
sense.
Not only that, you are from academics. You want me to give all the footnotes and references and
Yeah.
researches. I will try to do it my level best.
Sure, sure, sure.
Okay.
Yeah, do of course, a lot of input from me, like so that it'll be like very catchy and this thing like
Yeah.
what a student point might be looking at, because
Correct. Correct.
we deal with direct students.
Super. Sure. I'll
Thank
try
you,
to
thank you,
add those footnotes and all. But
thank
this
you.
is, see, I finished my engineering in 96. And from 1999, I'm mostly into IT. So that this is just my point of view. Okay. In a very
Yeah,
high
yeah,
level.
yeah. It's fine,
Right. See,
fine, fine.
I'm summarizing 25 years of IT in one slide.
Yes,
So obviously,
yes.
I'm not putting grid computing, and I'm not putting OpenStack, which had a
Yeah,
potential
yeah,
to
yeah,
become this cloud
yeah,
computing,
yeah, yeah.
which I personally
Yes,
loved. OpenStack, I
yeah,
liked, and it had a potential, but
mm,
unfortunately, it did not become cloud. But this is the
yeah,
ground reality. I might have loved
yeah.
OpenStack, but then it
Mm,
fizzled out. Okay. So now, this is how Amazon came, and then from Microsoft, they started Azure. After they started seeing this AWS being successful, they started, and then Google Cloud started, and then many other people started, and then this whole cloud computing is itself is expanding, and then slowly this on-premises data center is contracting. And one of the documents I saw, this is contracting around 5% every year, and this is expanding like around 5% every year, approximately. Okay, so this is expanding, this is contracting, because having a data center is expensive, and then you need to have people, and you have to manage it, and you cannot do auto scaling. Like on Monday morning you need 1,000 servers, and Tuesday morning you only need 10, then you cannot do it here. Only you can do it here, right? So there's a concept of cloud bursting, where I will have my data center, I'll have my critical load and all those things, but then if I want to have some reports and all which doesn't have sensitive data, then I will export the data to the cloud, do the computing, and then bring my data back, and I destroy my virtual machines, and I stop paying. So there is mix and match is possible. Okay. So now, then on March 20th, 2013, Docker was released. Docker was um, a container creation and management platform and tool. The whole idea of taking your whole application and packaging is like 30-year-old idea. It is not new. There were many ways it was done. It used to be called BSD jails, and even in Linux, you could do in Linux in year 2000 only, 2000 also, some sort of containerization. It existed even then. There are multiple ways to do it, but then Docker as a company picked up this idea because they had a website and they used to isolate their computing. So they made it, and then they saw and they released it as a free and open source software. And they saw thousands of companies in like few weeks started using it. And then they thought, okay, let us build this Docker company, and they started bringing up on tools. Now Kubernetes, as you know, even before year 2000, Google was running some sort of, like a containerized application at scale. Now they saw, and they were also trying to, they had their own containerization tool, and even they developed one and released it open source called Let Me Contain That For You, like LMCTL or whatever, some thing. So they also released it even before Docker to public, free and open source. But then suddenly when Docker became famous, uh, Google's team came up, okay, let us, so let the whole world use Docker for the containerization or app packaging, but the orchestration, which we have been doing for more than 10 years, and then billions of containers per week, let us take that let us build that orchestration tool and then release it free and open source, so that when developers create Docker, instead of that let me contain that for you container, which is Google's free and open source, even if people want to use Docker, so be it. But this orchestration tool, let it be Kubernetes, is what they thought. And then they developed the software, released it on June 7th, 2014, is what, like 6+ years ago they released. And then I think same week, I remember I saw somewhere in Hacker News or somewhere, hey, this even when Docker released, I still remember that. And even when Kubernetes was released in 2014, I still remember it. My first question is like, how do you even pronounce this? Kubernetes. Like, why would anybody want to have such a name? Is what my initial thought was when I heard when the announcement was made. But then lots of companies had this problem, and everybody saw the benefit of Kubernetes, and then Kubernetes also started exploding. Lots of people started using. Now Kubernetes runs on being a free and open source software. It runs on premises. You can download Kubernetes software, then you can run it. And the cloud vendors, obviously on Google Cloud, it ran natively from day one because the Google engineers worked on Google Cloud. So they are all internal people. So they released it. And then AWS and Azure also released their own managed Kubernetes clusters. So we need not even set up a Kubernetes cluster, just which I'm going to show you later in this session. You can go to Amazon or Azure, Google Cloud, Oracle Cloud, IBM Cloud, any of this cloud, and two, four or five mouse button clicks, and then you will have your own like highly scalable, globally distributed, exclusively to you Kubernetes cluster, only at 10 cents per hour. Okay, they will manage it. Google engineers will take care of it. If you use Google Kubernetes and Google Cloud, Microsoft engineers will take care of your Kubernetes management on Azure, just 10 cents an hour. And some of these also, if it is running only on one global region, it's like even free. And many of these cloud computing vendors give even a managed Kubernetes free, because they make money on the compute nodes. Because if you create a Kubernetes, managed Kubernetes cluster in any of these cloud vendors, you need compute nodes to deploy your workloads, right? So there they make money. So they're giving, okay, we manage your Kubernetes for free. But then they know, obviously, you might create 10 servers or 1,000 servers. With that, they're going to make money, right? So Kubernetes is like exploding on premises and also on cloud. And
Yeah,
2017, yeah, please.
sorry to interrupt.
Yeah,
There are two questions, maybe very
yeah,
silly questions.
I love
Is
it.
that
Yeah.
if that Docker is just only with packaging,
Yeah.
it Kubernetes is packaging plus orchestration, right?
No, for
Only orchestration.
Kubernetes, correct. See, for Kubernetes, see, a developer creates takes all his source code and compiles it and puts it into a Docker container. Okay.
Yeah,
So
yeah,
your image is ready, and that
yeah.
he will upload it to something called a registry or a repository of Docker.
Fine.
Now, when it is stored, then you go to
Okay.
Kubernetes and you'll create a deployment YAML file, which will
Yeah.
say, okay, I need 2 pod to 200 pod, and this is the container image. And you're going to say, my container image is in Docker Hub or hosted repository. Somewhere you have to store it,
Okay.
so that
Okay.
Kubernetes will go to that URL and pull it and deploy it. Whether you want 2 pod or 2,000 pods, it will download it once and then distribute internally, or download it once per node. Like if you have 100 nodes and if you want to have 2,000, it will only download it once, the same image.
Okay.
So
Okay.
the Docker container or the image which the developer has developed has to be uploaded to a Kubernetes accessible um, Docker registry or repository. It can be your on premises, or it can be in Docker Hub also, which is publicly
Okay.
hosted, free for hosting. Obviously, if you pay whatever, some $17, they'll give you lots of storage and stuff. But the Docker registry, the Docker hosting service itself can run in a Docker, and it is free and open source, and it can run on your premises.
Fine. Like, like if this was the feature that's to be there for all the cloud based things, why Amazon has missed it?
Amazon has missed
Or
what?
like, I may be silly, but the things like if this Kubernetes support is
Yeah.
there in there as a feature of Amazon?
Yes, it is called EKS, Elastic
Okay.
Kubernetes Service, which is managed by hosted in Amazon, managed by Amazon, only 10 cents per hour.
Okay.
It's called EKS. Just to extend that, in GCP, it's called GKE, the hosted
Okay.
managed 10 cents per hour Kubernetes. which is going to control your whole, orchestrate your millions of parts and thousands of nodes. It's called GKE in GCP, AKS in Azure, Azure Kubernetes Service, EKS in AWS, Elastic Kubernetes Service.
Fine.
Okay.
So I just wanted to know like what it is their way of this Kubernetes offering.
Okay, it's called EKS, which I have a link and I will share with you all in one of the, let me see, is it here or is it here? See, AWS EKS training.
Yeah.
So here, there's more details you can find out.
Yeah.
This is introduction and this thing. And you know what? Another surprising thing. So, so this is AWS Kubernetes service with a lot, tons and tons of documentation. You can come back and read. This is really interesting for me and for you all also. Okay, so now there is like everybody took Kubernetes and they were hosting on their premises, so that their interest is not Kubernetes. They want consumers to come and deploy in Kubernetes so that they'll consume more nodes, the compute nodes, and they'll make money. That is their fundamental interest. Okay. Now, to my surprise, Amazon took their EKS and they open sourced it so that I can install on my premises. It's called EKS Anywhere.
Okay. They are giving their own version. You can use it your on premises,
on our
not only on my
premises.
cloud.
Because
Like it's kind of making it very familiar, making them use it.
Correct. So that everybody will
things,
download and install on their laptops and on their premises, and then when it expands, they'll come to Amazon Cloud.
Much like Android.
How it is like Android?
I mean to say that like to make it more number of users, make it open source and make it free.
But why they should give it to me and you? See, it is already running in Amazon Cloud, and anybody can go to Amazon Cloud and create it and run it.
So,
why should they give it to you and me?
As I told you, to make more people familiar and to penetrate more markets.
Correct. But what if I download and create a services company called EKS Everywhere, and then I put my name on it and my brand on it, and I start selling and I compete with Amazon's EKS? It's possible.
They don't mind, or maybe they don't. They are not losing.
No, it is good. Okay, now, okay, this leads to our next point, which I want to stress is that, see, all these years, operating system wars, Microsoft hating Apple mocking at Microsoft, and Oracle telling we are the greatest database in the world, and IBM DB2 saying we are, right. So there was always competition, animosity, and then there was Lotus Notes, then Excel came, then somehow Excel killed Lotus Notes. There was always patent wars, copyright wars. Always some company was always hating its competitors, and there was fights, and then people were suing. Okay. Now, Kubernetes is the first software I've seen in my 20 years of my IT career that everybody is loving it and everybody is supporting it. There is no hatred for Kubernetes from any company in the world, any vendor in the world. Either they support it, for the first time ever. Like, even if you see Amazon Cloud, right? Most of the Amazon Cloud people, they don't use the word, even in their marketing, this thing, they don't want to use the word. There is a few terminologies they would prefer not to use. It's called hybrid cloud. Amazon doesn't want to use because they say we are the cloud, always use our cloud. Okay?
They don't want to use, and we don't want hybrid.
Right. So Amazon, see, there is a friendly cutthroat competition between AWS and Azure and GCP, right? They'll give big discount. Like if you call Google Cloud and say, hey, look, Amazon is giving me 30% discount, immediately Google Cloud also will give you 30% discount. If you are spending $100 million, for example, or above.
It should be.
So there's a humongous competition. Sometimes, some Amazon engineer will go to Google Cloud and or Azure Cloud and they'll sue each other and all those things, right? But for the first time, I'm seeing, let me show you this landscape. This is a website which is one of my favorite. If you see here, like if you see the platform and hosted
Yeah,
computers
see,
and all those things,
really
right?
enormous,
Everybody loves
exhaustive.
Kubernetes. There is nobody saying no, Kubernetes is bad, it's a failure. Like nobody's bad mouthing. Like, and I'll show you one interesting thing. Very recently, even Apple became a sponsor for Kubernetes.
Wow.
Oh, I was thinking like, why would they want to do and all? Now, Apple is like donating lots of money to this foundation,
Right.
right? They said for whatever reason, we want Kubernetes to be successful.
Yeah.
Right? I think they became. Let me show you here members, and you see here all large companies in this world are like supporters of Kubernetes, and everybody's wants the success of Kubernetes. This is the first time where every vendor is like loving Kubernetes and supporting Kubernetes per se, and working hard to take their applications to ensure it runs on Kubernetes. Nobody
Yeah,
want to
good
miss this boat.
fortune. It's really a good fortune that as like Linus Torvalds came out with that in open
Yeah,
source where they have a lot of people.
yeah,
Fortunately, by God's grace, maybe the
correct.
Almighty's command,
Yeah,
there should be like a potential benefit to a huge
everyone.
community. Yeah,
Correct, correct. Yeah.
fine.
So
So
now, yeah.
I've not deviated your flow.
No, no,
Like,
we are happy. This is like knowledge sharing, and you should not only know the technology, you should also know the corporate fights and the philosophy and the history behind it,
fine.
and right. So that knowledge is the base. So technical
Yeah,
knowledge
yeah.
is a lifelong learning. Right.
And I think like I'll just like invite other participants also to be interactive
Yeah, yeah.
because it's just like we both are chatting.
Correct, correct. Yeah,
Please.
I've told them I want like more interaction. So only few weeks ago, even Amazon released their Kubernetes distribution to be downloaded by anywhere, and anybody can download, and you can even resell it to your local companies wherever you are, because the code is open source, right? I was really surprised when they released it to the public. Like anybody can download, and if you want VMware, you can run it on VMware on premises wherever you want, and they will even support it. And if you don't want support, you can run on your own, right? So that is another interesting thing about these distributions of Kubernetes. And then because Docker is becoming a the basic way how applications are being packaged and deployed, Kubernetes is expanding. And then even in Kubernetes we can build serverless, which most of these cloud vendors are also providing their own cloud functions and serverless. But in Kubernetes you can build it. But the advantage with Kubernetes is that it is vendor neutral. See, if you have some sort of functions and serverless, if you're running on Kubernetes, then you can run on premises and any of these clouds, because Kubernetes runs everywhere. But then if you have Lambda, for example, that only runs on Amazon cloud, AWS, you cannot directly run in on Azure or GCP or on premises also. So there's a vendor lock-in. But if you have your containers as serverless run on Kubernetes, then you can run on your premises if you want, or your customer premises, or in any of these clouds you can run. There is no vendor lock-in, right? Over time, if you can containerize your application as a Docker container, and then you can put on Kubernetes as an deployment, or even you can run as serverless. But personally, I would consider to run even your serverless on Kubernetes. Otherwise, if you take AWS's serverless Lambda platform, then if some 6 months later or 1 year later, if you want to migrate to Azure or GCP or on premises, there'll be more effort you have to do to migrate it, right? So
So it's better to go
Vijay,
in Kubernetes from the beginning.
Yes.
So you'll not have a problem of migrating at the later stage.
Correct. Migrating in the sense, it will have problem, because I've seen even this cloud vendors, right? They want to lock in as much as possible. they don't want
Somebody
to
else
have
is
an exit policy.
somebody else is having a question, I think.
Yes,
Ajay,
I'll go there. One second. I'll just finish off this thing. See this now. I'm not only talking about technology. You should also keep in mind vendor lock-in. Every vendor, they will want to lock you in so that next 20 years you are like, constrained there. And obviously now let us say one fine day Amazon raises their price, and then GCP cuts their cost because of some new technology they created or new computing capability, and then you want to go there. But then even if it saves say 30% of money to go to Google Cloud or Azure from Amazon, but then if your effort to migrate is like 50 percentage, then you'll hesitate. Maybe you'll not even migrate, right? So it is the nature of every cloud vendor, whether it is IBM or Oracle or Microsoft, to try to lock you in with some sort of incompatibilities or whatever. But then as architect and developers and operations people, we should ensure before choosing any platform or any framework or any stack or any technology that you can easily migrate across clouds and have freedom to test it on your laptop or some sort of on-premises cloud, and then there's a huge ecosystem, right? So that we should always keep in mind. I want to make it clear now. Okay, sorry, go ahead. Who had this next question?
Yeah, Ajay, this is Durga.
Yes,
So,
Durga.
in order to understand Kubernetes better and its orchestration and all,
Yeah.
do we need to have a prerequisite of setting up the Docker container and
Yes.
the
Correct.
repository and all? So, okay.
Yes, not repository, because there's lots of free repositories, and even you can set up a Docker repository on premises in less than 30 minutes. And to learn Docker itself, it'll only take few hours. Like to basic. Actually, I'm going to show this. We have even documented it. If you have got your code ready, building a Docker container is only 2 commands, which you can
Yeah.
learn in
Okay.
whatever, an hour.
Okay.
It will only take a couple of hours for you to learn sufficient Docker, where if you have a Docker file, if you have the source code ready, which is a job of a developer to create the source code, to put it into a Docker container, uh, uh, to put it into Docker container is one command, and tag it and upload to any of the registry is another command. So to know bare minimal, if your source code is ready, only you need to know 2 commands, which we have documented, which are going to share. Bare minimal. Obviously there's lots of other capabilities. It will not take like more than 5 to 10 hours to learn to use Docker, the basic things. In a day, any developer can learn and need to learn. Okay.
Yeah. Okay.
No big deal. And then we show you all those commands. We have documented it, how to, and specifically for Java, I also have Docker files, how to build a Docker container. If your code is Python or Go programming language and Java, all these things, I have samples which I'm going to share with you. Right. So yes, in this course, you will, each one of you will be forced to build at least one Java Docker container. The documentation is ready. Just follow, run these 2 commands, and your container is ready, built in a couple of minutes.
Okay. Sure.
Thank
you.
you. Pleasure. Okay. Any other question from anybody else? Okay. Any feedback you want to give me? Am I going too fast, too slow, or you already knew all of these things and this is boring? Can somebody else give? Yeah. Anybody else? Can you please give me your feedback?
This looks good. The flow is good, Ajay.
Okay.
So yeah.
Thank you.
We are
Yeah.
covering a lot of aspects. That's even better.
You should also understand some history, some philosophy,
Right.
and some reasons, business reasons, even before getting into technology. And this is the first session, right? Okay. So if there are no session, sorry.
Hello.
Yeah.
Ajay Krishna, Ramesh.
Yes, Ramesh.
I came from mainframes.
Oh, okay. Awesome. Welcome.
Actually, looking to what are the prerequisites I need to learn before this one? Direct, I can learn this one.
You can start from scratch. From today, you can start like see, already you know mainframe. It's not that you're a fresher out of college, right? You have seen production deployments, upgrades, patching, and maybe
Yeah,
you have
yeah.
seen year 2000 problem also. I mean, similar such problems, right? So it is good enough, and I'm going to start from scratch, and that is why I'm going very slow, right? I'm not even rushing, and there's going to be lots of hands-on labs, and I always welcome questions. So if you don't understand, stop me anytime, and there's lots of materials, and then more hands-on will be there. So if you ask me what is prerequisite, nothing. If you got a couple of years of experience in IT, and if you run few commands in a Linux command line, that is sufficient. So does anybody have never logged into your Linux command line and typed few dozen commands? Is there anybody here? Okay, if there is no such person, then you are all good. In 10 days, you will have at least basic confidence. Yes, I know Kubernetes. I can deploy an application, a Java application if you want, or a Python or a Go application. I can deploy on Kubernetes and I can scale it up, and I can destroy it and delete it and redeploy it in 2 minutes. That confidence, you will get it. And then you'll keep learning. It's not that end of story, right? Okay, so if this, I just want to show you in the top right. This is an IBM 5 MB hard disk. Okay, it cost like $1 million+, and it came in an aeroplane, shipped in an aeroplane, and it came. People brought in, but now you can buy like 128 GB, as thin as your nails, for like less than $50. What cost more than $1 million, but still the application deployment and production migration still a nightmare. Like even now, like till last year before, I mean, from the past 2 years, I'm only exclusively working on Kubernetes. Before that, uh, production upgrade, production restart is always nightmare, and they'll allow it sometimes. Sunday 11 p.m. Oh, they'll only give us 1 hour to restart or patch or upgrade, right? Still, IT is not like rock solid and reliable, even though the hardware is like million times more powerful and more capable and so much cheaper, right? So 5 MB is $1 million. Now in Amazon or any of this cloud computing, you can get a GB for 10 cents a month, right? One whole GB for the whole month is only 10 cents, right? Even though the hardware has come a long way, software is still pain to upgrade, pain to patch, dependency, and not easy to manage, and expensive to operate. Okay. Now, what are the problems Kubernetes can solve? See, currently, as I have 20 years of experience in IT operations, I can tell you, like one developer will say, "Hey, look, it is working on my laptop. It's not working on the server. It is your problem, not my problem," right? Because he will have some version of operating system and like say Windows 7 or 10 or whatever, and then server is Windows 2008. Obviously, it is not supposed to work. Or he will have some Windows, some Java version or Python version, and then the server will be Linux. It is obviously, and he will refer a file as C colons backslash something, and then, but actually in Linux it will be slash where and some folder, opt, all those things, right? So incompatible versions, and if I want to patch my operating system, the application binary is not going to work. It will fail, and application A depends on framework B, which depends on a component C, and then if you upgrade A, it will break B and C. Problem. So life has been like operations is not an easy job. We have to carry the pager or the cell phone 24/7. Anything can fail, and we should respond quickly. Otherwise, the users are going to scream, website is down, right? So all these problems, if you have Kubernetes, you will not have. Okay, that is one thing. And these are the data center responsibilities which I spoke, like we should take care of authentication. See, generally developers think, okay, my code is good, my algorithm is awesome, I've optimized my code. Dear operations people, please run it for me. Now they don't think is there sufficient compute, there's sufficient storage, the network is there, is the firewall open, can it connect to the internet? What if the server fails? Does the code has got the intelligence to self-heal? If the server restarts, will this application run the same way? And OS patches and upgrades and application failure. If the application fails for 1 out of 1,000 reasons, like what is the operation people supposed to know? How are we supposed to debug and fix it? We don't know. At maximum, the operations team can restart the application, but then if it comes back and errors out, we were clueless. Then we have to wake up the developer, or only they can fix it, right? And application upgrades and deployment, authentication, authorization, access, and backup and disaster recovery. Like generally, very rarely a developer will think, okay, if this code fails in this thing, I should have a backup here. Or if this whole data center is on fire or flood or earthquake, then how is my code supposed to run in the other data center? A developer generally don't think in that thing, but then we, the operation people, has to ensure there's a disaster recovery in another state or province or another country somewhere, so that if this whole data center or the whole city is on fire or earthquake, right? See, the ring of fire, the whole of west coast of USA and Japan, it's an earthquake like zone. So when you're hosting there, an earthquake can happen in Vancouver or Seattle or California, but then what happens to your data? So all these things, the operation people has to think and then have preventive measures for these things, right? So Kubernetes solves all of this problem in one go. Okay, now I have a small video in this YouTube. Yeah,
Before going to more slides, can you go back to two more slides back?
sure. This one or next one?
Here, no, next one.
Yeah.
Yeah, here I want you to spend some time between the virtual machines and containers. So, what is the advantages containers give over virtual machine,
Sure.
and what are the use cases where virtual machines are better than containers? I mean, if you are covering in our future slides, then we can skip for now.
Correct. I had a slide on that. Um, Okay, a little bit here. Okay, yeah, I have a slide, so I'll come to that in. Oh, that is just the next slide, huh? Okay, I'll
Okay,
come to that.
sure.
It's just the next slide. Okay, I'll go there, but then let us do a quick time check. Okay, so we actually scheduled it for 1.5 hours, but today we started a bit late. Now it is 9:30. I mean, another 5 more minutes. It's 9:30 for you all. So my basic question is, should we end in another 5 minutes and continue tomorrow as scheduled, or how do we do it?
Don't mind if you go.
Correct. We can overboard, but then for
Yeah,
most
it's
of
about
the
others' convenience.
correct. I know. Yeah. So because I don't know,
Hitesh,
it's a Monday morning and you might have commitments, so I don't want to drag it more. So as promised and as committed, let us finish the session in another 5 minutes as scheduled, because we are scheduled for 1.5 hours only, right? So Monday morning you will have your own work-related task, and then we should continue tomorrow is what I think. What do most of you say?
Yeah,
Yeah,
Jay,
let's do
so
that.
we can close with a logical completion of whatever.
Correct. Okay. Based on whatever we committed, which is there
Yeah,
in our
even if it
calendar, we
takes
will end
more
it.
another 5-10 minutes more, also I
Correct.
think it
Correct.
should be okay.
Should be okay. Oh, super. So I'll aim to finish as scheduled. So, and we'll continue tomorrow. Okay. So now I have a video here, which you all can watch later also. 5 minutes, and this is less than 5 minutes video, I believe. So it is better that I share this so that it goes to your mind. Give me 1 minute. It is better that we watch this video. Oh, sorry, it's in my other screen. Let me bring it here. Or we could also go from here. Okay. Sorry, not that video. Yeah, this is the short, just 3-minute video. Do you hear the audio?
No.
You don't, right?
Audio is
Okay.
not.
Then
we are not,
let me talk. Thank you. See now, as we spoke this much time now, this is a high-level 3D animation which I created earlier, which gives you a high-level view of what is Kubernetes and what are the components at a very, very high level. Okay, so now here if you see, Kubernetes has got mainly a master nodes, which is highly available in the left side, if you see, and this is the Kubernetes administrator we're going to set up. And then we will have the developers here who will use an IDE to develop the code and put the code in Git repo and then CI/CD build out. And then the application the application definition will be used to deploy onto Kubernetes. And then the testers and the actual users, testers will be few, developers will be few, and this is the Kubernetes operation will be few, but then you can have as like, thousands or millions of users as much as you want. And so if you see here, these are the two master nodes of Kubernetes, which has got this components here in a very high level, right? In the simplest possible way. So Kubernetes has got master nodes, which is going to manage the whole of Kubernetes cluster. All the logic and the intelligence and scheduling and the DNS is present on the master nodes of the Kubernetes cluster. And it can have one to thousands of nodes, where which all the deployment is going to be present. You are going to deploy onto that. And then the SRE or the operations people will have the responsibility to set up the Kubernetes cluster from scratch. And a developer is going to use her favorite IDE to develop the code, put it into a Git repo, and use a CI/CD pipeline to build the Docker container and deploy it into a registry. And then Kubernetes cluster, when you have this app definition deployed onto this Kubernetes cluster, then Kubernetes cluster will pick up from the registry and deploy it the way you want it. This is a high level animation which contains all these things. I have half an hour long animation also, which I am going to share the link with you all. At your convenient time later, you can go and watch it. Okay, so now it is time. So I want to end this. If you don't have any questions, I'm going to end this recording and then we'll continue tomorrow. And I'll try to upload these videos in the next couple of hours so that you can ask your colleagues or somebody also to watch this.
Thank you, Jay. Thank you very much.
Pleasure. Let us continue tomorrow. Anybody has got any other questions? If not,
So
have
Jay,
a great Monday.
is
Yeah.
the cluster management and everything, is it set up somehow on the basis of Hadoop cluster? Because I'm seeing there are two master nodes and then there are multiple child nodes. That kind of cluster arrangement is there.
Correct.
So is it something sitting on top of Hadoop?
Not at all. Not at all. See, this is
Okay.
infrastructure. You can deploy Hadoop on Kubernetes. Kubernetes is the infrastructure layer on which you deploy everything, including Hadoop. Hadoop is just an application.
Okay.
Right? So this is infrastructure. It is like the Linux or Windows operating system on which everything will run. This only needs Linux operating system to run. You take some Linux operating system, and then you deploy Kubernetes on it, and then Kubernetes will orchestrate your billions or millions or thousands of containers.
Okay.
Okay.
Yeah.
Thank you.
Yeah.
Okay, let me stop my recording. Stop recording.